gas prices in the United States have already crossed a level that most households recognize immediately. By late April 2026, the national average had reached roughly $4.18 to $4.23 per gallon. In California, the average was approaching $5.97. For many drivers, that number is no longer a short-term spike. It has become a recurring cost. But the more important question is not why prices rose. It is why they are not coming down. Behind the price displayed at the pump, a different set of conditions has been developing inside the fuel system. Those conditions do not change overnight, and they do not reverse quickly. They are tied to production capacity, to how much fuel is actually being processed and delivered into the market, and to how much margin the system has to absorb disruption. By early April 2026, that margin had already begun to shrink. At the center of the system is refining capacity. Crude oil must be processed into gasoline and diesel before it can be used. When that process is interrupted, the impact is not abstract. It directly reduces the amount of finished fuel available for distribution. During early April, refinery disruptions began to affect production across the Midwest. Facilities associated with Marathon Petroleum, Phillips 66, and BP experienced outages that reduced output. These were not isolated incidents at a single location. The disruptions occurred across multiple facilities, affecting a region that plays a significant role in fuel supply. By mid-April, the combined effect of those disruptions reached approximately 800,000 barrels per day of lost refining capacity. That number represents finished fuel that is no longer entering the system. To understand the scale of that loss, it is necessary to look at how the system normally operates. Refineries process crude oil into usable products at a steady rate. That output feeds directly into distribution networks that supply gas stations, transportation systems, and industrial demand. When refining capacity is reduced, the flow of fuel into those networks declines. The system can continue to operate under reduced capacity, but it does so with less flexibility. There is less excess supply, fewer reserves to draw from, and less ability to respond to changes in demand. At the same time that refinery output was being reduced, demand did not decline in response. Commuting patterns remained stable. Freight continued to move across the country. Distribution systems maintained their schedules. The demand side of the system continued without interruption. This creates a structural imbalance. Production is constrained. Demand remains steady. The difference between the two must be absorbed elsewhere. Initially, that difference is absorbed through inventories. Fuel inventories act as a buffer between production and consumption. When production falls short of demand, stored fuel is used to fill the gap. This allows the system to continue operating without immediate disruption at the retail level. However, that buffer is not unlimited. As April progressed, inventory levels began to reflect the same pressure that had already appeared in refining capacity. According to data from the U.S. Energy Information Administration, gasoline inventories declined by approximately 6.1 million barrels. Crude oil inventories fell by about 6.2 million barrels. Diesel supplies dropped by roughly 4.5 million barrels. These are not small adjustments. They represent a sustained drawdown of reserves across multiple categories of fuel. The pattern is consistent with a system under constraint. When production is reduced and demand remains stable, inventories begin to fall. As inventories fall, the system loses its ability to stabilize itself. there is less capacity to absorb additional disruptions, and each new change has a more direct impact on the market. This is the environment in which prices began to move above $4 per gallon nationally. From the perspective of a household, that price increase appears as a direct cost. It is measured in the amount paid at the pump, but the underlying cause is not the transaction itself. It is the condition of the system that supports that transaction. When the system operates with reduced capacity and declining inventories, the price of fuel reflects that constraint. At the same time, another factor was developing alongside these changes. Exports of U.S. fuel products were increasing. Crude oil exports reached approximately 6.44 million barrels per day. Total fuel exports rose to around 14.18 million barrels per day, representing record levels for the period. These exports are part of normal market operations. The U.S. fuel system is integrated into a global market, and fuel moves across borders in response to demand. However, the effect of exports changes when domestic supply is already under pressure. As fuel leaves the domestic system, it reduces the amount available for internal consumption. When production is already constrained and inventories are declining, that outward flow adds to the overall tightening of supply. The system is not experiencing a single disruption. It is adjusting to multiple constraints at the same time. Refinery output has been reduced by approximately 800,000 barrels per day. Inventories have declined across gasoline, crude, and diesel. Exports are moving fuel out of the domestic market at elevated levels. Each of these factors contributes to the same outcome. The system has less available supply relative to demand. This reduction in available supply does not immediately appear as a shortage at the retail level. Gas stations continue to operate. Fuel remains available. Transactions continue as usual. But the underlying balance between supply and demand has shifted. That shift is reflected in price. When the system operates with less flexibility, prices adjust more quickly to changes in supply conditions. There is less capacity to absorb fluctuations, and the market responds by increasing the value of available fuel. For households, this response is experienced as higher and more persistent costs. The expectation that prices will return quickly to lower levels depends on the system regaining its flexibility. That requires production to recover, inventories to rebuild, and the balance between supply and demand to stabilize. By late April, those conditions had not yet been restored. Refinery utilization was reported at approximately 89.6%. This indicates that facilities were operating at a relatively high level of capacity overall. However, utilization does not capture the full impact of outages. Even with high utilization across available facilities, the earlier loss of capacity reduces total output. Crude production remains stable at approximately 13.6 million barrels per day. This suggests that the upstream supply of oil was not the limiting factor. The constraint was occurring at the refining stage, where crude oil is converted into usable fuel. This distinction is important. The availability of crude oil does not directly determine gasoline supply. Refining capacity determines how much of that crude can be processed into fuel. When refining capacity is reduced, the system cannot fully convert available crude into finished products. This creates a bottleneck. The presence of that bottleneck explains why fuel supply can tighten even when crude production remains steady. As these conditions persisted, the system began to reflect a consistent pattern. It was operating with reduced capacity, declining inventories, and sustained outward flow through exports. These are not temporary fluctuations that resolve quickly. They are structural conditions that take time to reverse. For a household, the implications are direct. Higher fuel prices increase the cost of commuting. Over time, those costs influence other areas of spending. Transportation expenses are embedded in the price of goods, and as fuel costs rise, they contribute to higher prices across multiple categories. The effect is not limited to the pump, it extends through the broader economy. At the same time, the system's reduced flexibility introduces uncertainty. When inventories are low and production is constrained, prices can change more frequently. This makes it more difficult for households to anticipate future costs. Budgeting becomes less predictable. This uncertainty is compounded by the fact that the underlying causes are not immediately visible. The price at the pump reflects conditions that develop across production, storage, and distribution. Those conditions are not directly observable at the point of purchase. They are reflected in data. By the end of April, the data showed a system under pressure. Refinery capacity had been reduced by approximately 800,000 barrels per day. Gasoline inventories had declined by 6.1 million barrels. Crude inventories had fallen by 6.2 million barrels. Diesel supplies were down by 4.5 million barrels. Exports were at record levels. Each of these figures represents a measurable change in the system. Taken together, they describe a market that is operating with less supply relative to demand. At this stage, it is not necessary to speculate about future conditions. The current state of the system already explains why prices have remained elevated. The system has not yet regained the capacity or flexibility required for prices to decline in a sustained way. For households, the result is already visible. The cost of fuel remains high, and the conditions that support that cost are still in place. This is the starting point for understanding why prices are not coming down. The next step is to examine how the loss of inventory and continued outward flow of fuel reinforce that pressure, and why those factors make the system more sensitive to change. As the system moved deeper into April, the initial loss of refining capacity began to interact more directly with another constraint that had been building at the same time. The reduction in production was no longer the only pressure point. The system was also losing the reserves that normally stabilize it. Inventories serve a specific function in the fuel market. They are not simply excess supply stored for later use. They are part of the system's ability to absorb imbalance. When production and demand do not align perfectly, inventories provide the flexibility needed to maintain continuity. When production falls below demand, inventories are used to fill the gap. When production exceeds demand, inventories are rebuilt. This continuous adjustment allows the system to operate without abrupt changes in availability. By mid-April 2026, that adjustment process was no longer operating in balance. Gasoline inventories had declined by approximately 6.1 million barrels. Crude inventories had fallen by about 6.2 million barrels. Diesel supplies were down by roughly 4.5 million barrels. These changes were not isolated to a single week or a single category. They reflected a broader pattern of drawdown across the system. The significance of that pattern becomes clearer when it is considered alongside the earlier reduction in refining capacity. When refinery output is reduced, the system relies more heavily on inventories to maintain supply. If inventories are already declining at the same time, the system loses two layers of stability simultaneously. Production is constrained, and the buffer that compensates for that constraint is shrinking. This creates a condition where the system becomes increasingly dependent on the remaining supply that is immediately available. The effect of this condition is not immediate scarcity at the retail level. Fuel remains available. Distribution continues, but the margin for adjustment becomes narrower. The system has less capacity to absorb further changes without affecting price. At this stage, price movements begin to reflect not only the current balance between supply and demand, but also the reduced ability of the system to manage future disruptions. This is where the role of inventories becomes critical. When inventories are high, the system can tolerate temporary disruptions without significant price changes. When inventories are low, even small disruptions can lead to noticeable shifts in price. The system becomes more reactive. By late April, the data indicated that inventories were not only lower, but continuing to decline. This suggests that the system was still using stored fuel to compensate for the earlier loss in production. At the same time, there was no indication that refining capacity had fully recovered. The approximately 800,000 barrels per day of lost output had not been fully restored. This means that the system was still operating under constrained production conditions, while continuing to draw down its reserves. This combination reinforces the same direction of pressure. Reduced production limits the inflow of new fuel. Declining inventories reduce the system's ability to compensate. The gap between supply and demand remains unresolved. As this pattern continues, the system becomes increasingly sensitive to external factors. Another factor that contributes to this sensitivity is the continued level of exports. Crude oil exports were measured at approximately 6.44 million barrels per day. Total fuel exports reached around 14.18 million barrels per day. These figures represent sustained outward movement of fuel from the domestic system. Exports are not inherently disruptive. They are a standard part of global energy markets. However, their impact depends on the condition of the domestic system at the time. When production is stable and inventories are sufficient, exports do not create significant pressure. The system has enough capacity to meet both domestic and international demand. When production is constrained and inventories are declining, exports reduce the amount of fuel available within the domestic market. This does not mean that exports are causing the imbalance. It means that they contribute to the overall tightening of supply under existing conditions. The interaction between exports and inventories is particularly important. As fuel is exported, it is removed from the domestic system. If inventories are already being drawn down to compensate for reduced production, exports accelerate the rate at which available supply declines. The system must rely more heavily on remaining reserves, which are already decreasing. This creates a feedback effect. Lower inventories increase sensitivity to change. Exports reduce available supply. Reduced supply increases reliance on inventories. Each step reinforces the next. At this stage, the system is no longer absorbing disruptions smoothly. It is reacting to them more directly. For households, this reaction is experienced through price stability, or the lack of it. When the system operates with adequate inventories and full production capacity, prices tend to stabilize after an increase. When the system operates with reduced inventories and constrained production, prices are more likely to remain elevated. This explains why prices that have already risen above $4 per gallon have not declined quickly. the conditions required for a sustained decline are not yet present. Inventories would need to begin rebuilding. Refining capacity would need to return to normal levels. The balance between supply and demand would need to stabilize. By late April, none of these conditions had been fully achieved. Instead, the system continued to operate with the same constraints that had developed earlier in the month. At the same time, refinery utilization remained at approximately 89.6%. This indicates that available facilities were operating at a relatively high level. However, utilization does not account for the capacity that is offline. Even with high utilization, total output remains lower if some facilities are not operating. This distinction highlights the structural nature of the constraint. The system is not underperforming in terms of effort. It is operating with reduced capacity. Crude production remains steady at approximately 13.6 million barrels per day. This suggests that the upstream supply of oil was not the limiting factor. The limitation continued to exist at the refining stage, where crude is converted into usable fuel. This creates a situation where raw input is available, but the ability to process that input into finished products is constrained. The presence of this bottleneck reinforces the pressure created by declining inventories and sustained exports. Even if crude supply remains stable, the system cannot increase gasoline output without restoring refining capacity. As long as that capacity remains reduced, the flow of finished fuel remains limited. For households, the result is a continuation of the same conditions that led to the initial price increase. Fuel costs remain elevated. Price movements remain less predictable. The system does not return to a lower cost equilibrium quickly. At the same time, regulatory attention remains focused on how prices are being set at the retail level. Investigations in states such as California and Nevada continue to examine whether price increases are consistent with underlying cost changes. These investigations are triggered by localized spikes and consumer complaints, but their outcomes depend on detailed analysis of pricing data. The existence of these investigations reflects the complexity of the current environment. Prices are rising due to measurable supply constraints. At the same time, regulators are evaluating whether those increases are being amplified beyond what those constraints would justify. This dual dynamic adds another layer to the system. On one side, the market is adjusting to reduced supply and declining inventories. On the other, regulatory oversight is assessing whether pricing behavior aligns with those conditions. For households, the distinction between these factors is not immediately visible. The price at the pump reflects the combined effect of system conditions and retail pricing behavior. The underlying causes require deeper analysis. By the end of April, the broader pattern had become more established. Refinery capacity remained reduced by approximately 800,000 barrels per day. Inventories had declined across gasoline, crude, and diesel. Exports continued at elevated levels. Prices remained above the $4 threshold nationally. These are not independent developments. They are interconnected components of the same system. The system is operating with less supply relative to demand and with fewer reserves to manage that imbalance. This condition does not resolve immediately. It persists until the underlying factors change. As long as production remains constrained and inventories remain low, the system continues to operate under pressure. For households, that pressure is reflected in sustained fuel costs and the broader effects those costs have on everyday expenses. The next stage of the analysis is to examine how these conditions translate into longer-lasting price behavior and why the system does not quickly return to lower price levels even after the initial disruption has passed. By early May 2026, the system had not returned to balance, and the conditions that had developed through April were still in place. Refining capacity had not fully recovered from earlier disruptions. Inventories remained lower across gasoline, crude, and diesel, and export levels continued to move fuel out of the domestic system. These were not temporary distortions. They were ongoing constraints that continued to shape how the market functioned. Refinery utilization remained at approximately 89.6%. Indicating that available facilities were operating at a relatively high level. At the same time, crude production held near 13.6 million barrels per day. These figures suggest that the system was active and functioning, but they do not reflect the capacity that had already been lost. The earlier reduction of roughly 800,000 barrels per day in refining output continued to limit the total volume of finished fuel entering the market. This distinction is central to understanding why prices remained elevated. The system was not inactive, and it was not failing to produce fuel. It was producing less than it normally would under full capacity, and that difference was being absorbed elsewhere in the system. Inventories had already been drawn down to compensate for that difference. Gasoline stockpiles had declined by approximately 6.1 million barrels, crude inventories by 6.2 million barrels, and diesel supplies by 4.5 million barrels. These reductions represented a sustained use of reserves rather than a temporary adjustment. Inventories function as a stabilizing layer within the fuel system. When that layer is reduced, the system becomes more exposed to fluctuations in supply and demand. Each additional change has a more immediate effect because there is less stored fuel available to absorb it. At the same time, exports continued at elevated levels. Crude shipments remained around 6.44 million barrels per day, and total fuel exports were near 14.18 million barrels per day. These flows continued to move fuel out of the domestic market while inventories were already lower. The interaction between these elements defines the current structure of the system. Production capacity remains constrained at the refining stage. Inventories have been reduced across multiple categories. Exports continue to draw supply outward. Each factor contributes to the same condition, a tighter balance between available fuel and ongoing demand. This condition affects how prices behave over time. When the system has sufficient capacity and inventories, prices tend to adjust and stabilize after a disruption. When capacity is constrained and inventories are low, prices are more likely to remain elevated because the system does not have the flexibility to return quickly to a lower cost balance. For households, this is experienced as persistence rather than fluctuation. Prices do not simply rise and fall in short cycles. They remain at higher levels for longer periods because the underlying conditions have not been resolved. The effect of sustained fuel prices extends beyond the cost of filling a tank. Fuel is a foundational input in transportation, and transportation is embedded in the pricing of goods. As fuel costs remain elevated, they influence the cost structure of distribution networks. Over time, those costs are reflected in the price of goods that depend on those networks. This transmission is gradual, but it is consistent. A higher cost at the pump contributes to higher transportation expenses, which in turn influence pricing across multiple categories. The result is a broader increase in the cost of everyday goods and services. At the same time, The reduced flexibility of the system introduces uncertainty. When inventories are low and production remains constrained, prices can change more frequently in response to relatively small shifts in supply conditions. This makes it more difficult to anticipate future costs. For households, this uncertainty affects budgeting. Expenses that were previously stable become more variable, and the range of possible outcomes becomes wider. The impact is not limited to a single purchase. It affects how households manage recurring costs over time. Regulatory oversight continues to operate within this environment. Investigations in states such as California and Nevada remain focused on whether price increases at specific locations are consistent with underlying cost changes. These investigations rely on detailed comparisons of wholesale prices, transportation costs, and retail pricing. By early May, no large-scale penalties had been confirmed. The investigations remained ongoing, reflecting continued monitoring rather than completed enforcement actions. This indicates that, while price increases have been significant, determining whether they exceed cost-based justifications requires further analysis. The presence of these investigations adds a layer of accountability, but it does not alter the structural conditions of the market. The primary drivers of price behavior remain tied to production capacity, inventory levels, and the flow of fuel within and beyond the domestic system. As long as refining capacity remains below its previous level, the system continues to operate with reduced output. As long as inventories remain lower, the system continues to have less ability to absorb disruption. As long as exports remain elevated, the domestic supply continues to face additional pressure. These conditions do not resolve simultaneously or immediately. Each requires time to adjust. Refining capacity must be restored. Inventories must be rebuilt. The balance between supply and demand must move back toward equilibrium. Until those changes occur, the system remains in its current state. For households, the implications are already established. Fuel costs remain higher than previous levels, and the conditions supporting those costs are still present. The system has not yet regained the flexibility required for prices to decline in a sustained way. The pattern that developed through April has carried into early May. Production remains constrained. Inventories remain reduced. Exports remain elevated. Prices remain above the $4 threshold nationally, with higher levels in certain regions. These are not projections. They are the conditions currently shaping the market. The fuel system continues to operate, but it does so with less capacity to stabilize itself. That reduced capacity is reflected in the persistence of higher prices and the broader impact those prices have on everyday expenses. This is the current reality of the system.